What else distinguishes this machine from the others? I also process lacquered, acrylic and veneered fronts on this drill. Hello everyone, today I'd like to present the MSline 704 multi-spindle drilling machine. This is a machine developed under a Polish patent and license manufactured by the Maggi company. It's called MSline 704. Where does that name come from? MS represents my initials and 704 indicates the distance between the machine's outermost spindles. The machine is constructed with a 23 spindle head. It's a machine designed for the production of custom-made furniture. I constructed this machine for the specific needs of my own carpentry workshop approximately 8 years ago. It served as my personal secret for achieving rapid production, maintaining very high quality, all while incurring only minimal investment outlays where the primary operational axis. In this particular instance, is oriented perpendicularly to the spindle head rather than being parallel. Consequently, it functions as an axis independent of the 32mm system on the main axis. What else distinguishes this machine from all the others? From a technical and visual perspective, the fact that it's a ready ergonomic workstation, fully equipped and prepared to carry out 100% of the holes necessary for furniture production. For me, it drives the entire production process. It comes standard with a measuring frame, which is a permanent and integral component of the drill. On each of the rulers, you'll find five individual stops. The complete set includes a magazine, naturally without any tools, because everyone has their own specific technology, and I certainly wouldn't want to impose anything on anyone. We have a complete set of spacers, all crafted from durable polyamide, with each one precisely measured, ranging from 1 to 32mm. On the gauging frame, there are beams equipped with rollers that, when positioned vertically, effectively extend the surface of our workbench. We are working in an area behind the machine in which up until now no one really operated these machines. As a result, the operator always stands directly facing the work surface, which enabled us to construct a pedal that controls the pneumatics on a pendulum mechanism. This is a very convenient solution. The pedal won't slip away from us. It won't hide beneath the machine. With this machine, there's no need to move the pedal all around it. The next key component we have is the side fences, which are mounted on a robust dual guiding system. This design allows us to maintain a very rigid and precise angle in relation to the main cutter head. Furthermore, these side fences can be elevated up to 8 full centimeters, ensuring that we can also comfortably and effectively work with various wooden pieces. Since I also patented the height adjustment of the pressure beam in the form of a comb, you can process material here up to 200mm thick. Pause, very simple to use. At pause, the beam is quickly adjusted. Everything is operating very smoothly. Then on the clamping bar, we have 2 clamps installed, which in our machine are powered by 2 completely independent circuits, at the end of which we have the control valves. So when you're working on some more delicate parts and you're planning to spend a longer time on just one side, we can move the clamping pressure away and then close the valve. This significantly increases our work safety. And also, this actuator just doesn't wear out on us. It doesn't fatten unnecessarily. At the bottom of the press, we have felt pads as standard. I also drill on this machine lacquered fronts, acrylic fronts and veneered fronts. The main idea here is to ensure that you don't damage the front material. You'll find 2 230-volt sockets allowing you to plug in even a small compressor without needing a dedicated compressed air system. You can easily plug in your phone to a charger and then store it securely inside the cabinet. There is an RT at the machine entrance. This is where we can power the compressor, and at the machine's entrance is the main air valve. We turn off the machine after work, ensuring it is not under pressure when idle, as this would wear out all the seals and pneumatic components the most. The support arms to which the clamping bar is attached in the MSline models have been extended to a length of 45 centimeters. This enables us to work on very deep installations, such as, for instance, that cabinet built into a sloped wall, which measures 900 millimeters in depth. The numbering of the drill bits has been changed, as well as the reference points in relation to the zeros. We no longer have the 0 point in the machine center, as is customary. In my case, drill 0 is replaced with drill number 12. At this moment, we have 2 zeros on the side guides, which are not fixed since we have set a nominal 0, but by adjusting the side guides, we change the position of this 0 to an initial. Instead of a single fixed 0 on the drill axis in the middle, we now have 2 zeros as the side guides, and the numbering starts from 1 to 23 and goes the other way. So operating on the left side as the left side guide, we have the entire range of the workbench available. By drilling from right to left, meaning drill number 1 on the right side is drill 23 for the left side. What was the result? That we doubled the working area of this machine without actually changing the surface even by a millimeter. Of course, the heads with the frame, the gauge frame, can be set to the horizontal position. It's worth mentioning the reference point in relation to 0 here. So 0 in a standard drill, 0 in the horizontal position is equal to the machine stable. Of course, this cannot be changed, but it was equal and served as the reference point for the scale on the rulers. When it comes to my specific concept, 0 value in the horizontal position is not equivalent to the 0 points found on the scales of the datum frame. So having the setting at 9 and let's say 2 in the horizontal position for drilling an 18mm plate, in the vertical position on the rulers, we have it roughly calibrated by these 9mm. So we set the actual dimensions to which we don't have to add those 9mm. Here we have a solution patented by Maggi many years ago. Spiral system, very simple, intuitive solutions. We have 4 drill lengths here and 4 scales on which we adjust the drilling depth for a given drill, right? So for example, when drilling with a drill bit 5754 dowels in a vertical position, we set it to say 15mm, then we lock it. And that's really all. The adjustment is smooth, so it's very nice to use. Returning to setting the 0 in the horizontal position in relation to the rulers, here we have it set to 9mm and 2/10 of a millimeter, because an 18 board always has a little more than 18. And now I will show you how we calibrate this gauge. There are 2 rulers on the lines. One is a short 10 cm measuring stick, and I use the gauge solely as the reference point for calibrating the main measure. Putting 9mm on the head for drilling an 18mm plate, we simply calibrate this measure by those 9mm in the profile. The adjustment of this measure is as wide as the stroke of the head. So we can move this gauge in the profile by 55mm, but we needed to move it by 9, right? So here we have the head shift of 9 set for horizontal drilling in the middle of the board. And now we have calibrated this gauge by 9mm. How? On the calibration gauge, which serves as the reference point, we set 9mm. We move the stopper to the main measure. We're going to loosen the adjustment right here, and then we'll move it in such a way that we can precisely set our 0 point on this particular side of the bumper. Now, if we're only working with an 18mm plate, by performing these specific actions just one time on the head, And on the guides, we essentially may never have to come back to this task ever again. The tool magazine is equipped as standard with these hangers on which we have mounted polyamide spacers. Perhaps we can do simulation of setting up the machine. We'll show that instead of adjusting the rib fence using this digital gauge and knob, how we perform the task of setting the distance for a specific drill bit. Let's say we want to achieve that standard 37 for woodworking. My first drill bit setting is 18. Of course, that's a nominal zero. Everyone can set it however they like based on their own idea. Though through all these years I've been making furniture with this drill press, 18 for the first bit has worked perfectly for me. Yeah? I would recommend trying to work with this setting on the first drill bit. It's 18 plus 32, so on the second one we have a machine. In order to achieve a final dimension of 30, 50 minus 13 gives us 37. And with that, we have effectively completed the entire machine setup process. There is need to dismantle the side fence, for example, to drill into a deep cabinet, such as this angled one here, for components with a depth of 900 millimeters. We can quickly and easily remove this fence. And we have a dedicated spot where we can comfortably place it aside during our working hours. Similarly, we can perform this exact same operation from the opposite side. It's worth mentioning that the MS704 possesses all the functionalities of a conventional older type machine, but once someone begins to operate within this new system, they will genuinely forget any desire to work with outdated technologies. The machine is in fact very simple and intuitive. That was my core idea. I designed it so my employees could also quickly make use of it. Essentially, this machine completely handles the entire production process 100%, specifically for drilling holes in my workshop. So it's what I'd call a central hub. The company's central facility, as you can clearly see, is situated right in the middle, with ample space surrounding it on all sides. However, I've already set up several machines in smaller woodworking shops, in what I would describe as larger garages. So the machine's total width, including its cabinet and magazine, is 1300. And from the side guide to the end of the measuring frame, the length is 2 meters.